Welcome to BKW Physics. I'm Mr. McConley, and today we're going to talk about electrostatics, the study of electrical charge. And a lot of things have electrical charge. Like you can take a balloon, rub it on your head, get it to stick to something. You've done that. You can move around real fast underneath the sheets, especially in the winter time, and get sparks coming off. Have you ever seen that?
Yeah.
Interesting. That's electrostatics. But electrostatics basically talks about when you have a nucleus and you have your electrons that are around the outside, what you're doing is as you get further and further out, further away from the nucleus, these electrons are more easily or more readily available to be stripped away or moved away. So if you take that balloon example, and we take that balloon and we rub it on our hair, you are taking these electrons that are on the outside shells, you're pulling them off, and now, if this is my lame picture of a balloon, you're pulling them off and you're sticking them all over the outside of the balloon. Now we'll talk more later about why electrons seem to gather on balloons and other things like that. That's a whole other little topic. But for right now, you got to know that you're stripping the electrons and you're collecting them in one area. Once you collect them in one area, now this whole balloon is charged in what way? How is this balloon charged once you have electrons all over it?
Negatively.
Negatively. And if this is negative, if you get near things that are positive, it'll be attracted. Or other things that are negative, it'll be repelled. Easy concept, right? That makes sense. The way I'd like you to talk about charge, though, is maybe a little different than you've said it in the past. If you are negatively charged, you have an excess of electrons, excess. Then what must it be for if something's positively charged? Well, you can actually say you have a deficiency of electrons. You're lacking electrons. So you either have a deficiency or an excess of electrons. And if you can think of it that way, you're thinking of the heart of the matter of what's really going on, which is transferring electrons, and that's why you have charge. Okay. Everybody knows that like things repel, opposite things, positives and negatives, attract. I'm not going to go into too much detail because you've known that for a long time. But what you probably haven't seen is some of these electrostatic demos that I'm going to show you now. We're going to go through them and then we're going to break them down in more detail, maybe on the whiteboard and maybe a little bit by explanation. So my videographer is going to kind of come over this direction. And if you can get in a spot, so people in the classroom, if you can get a spot where you can actually see what's going on here, probably the easiest just to do this. Stuck? Okay, there you go. So if you're going to kind of come around with the video so you can see this right here. People that are in the room, just get so you can see this. Now what you're looking at here is actually two pieces of, they're like aluminum foil, but they're gold foil. That's actual gold. It's just a very thin sheet of gold. And there's a reason for that, because gold is a good conductor of electricity. And it's hanging, and then there's a knob on the top. It doesn't seem like anything too spectacular, but what you can do with this, what you can do with this here, we got some fur here. If you're allergic to different animals, try not to let the fur get on you. So I can build up some static electricity here with this. So what I'm doing is, just as I explained before, I'm scraping the electrons off the fur of this animal, and I'm collecting the electrons on this wand, and this wand is made of plastic or rubber, because plastic and rubber are good insulators. So insulator, source of electrons. Good, I can hear it kind of crackling, so I know I'm getting some good static electricity. And if you watch these two pieces of gold foil, you got to watch them carefully. When I start getting close, can you see them moving? I haven't even touched it yet. I'm just getting close. So watch again with the camera there. See how that starts moving when I get close? And when I touch it, boom. Now they actually stay like that too, for a while. Until I do something which is called grounding. This is another word you haven't heard before, maybe. But I can absorb an immense amount of electrons because in comparison to this little wand, I'm pretty big. So I can touch this, I can absorb those electrons. I didn't even feel anything, actually. And those electrons, those excessive electrons, went into me. And then, you don't really need to see it that well with the camera again because I'm going to do the same thing. I'm going to touch it again. I can, again, put some electrons there. So now I want you to visualize what's actually going on. This is a little bit harder, but we'll kind of do it piece by piece. So I collected electrons. What do you see on this in your mind's eye? You see a lot of electrons piling up on here, millions. Now, as I touch this, why do the electrons go into the gold foil? Well, it's a simple concept. Remember we said in the beginning, electrons or negatives don't want to be near other things that are negative, right? So if you're a negative and I'm a negative, we kind of are repelled from one another. Well, I just collected all these electrons and they're way too close for comfort here. So when I touch it to this gives them an opportunity for some of the electrons to go down here, and now they can be further away from, they can get some space, basically. So when I touch this, some of those electrons go down into the gold foil because that makes them farther away from where they came from, and now it spreads them out a little bit, and that's what they like. But why then do those two leaves, those gold foil leaves, why do they go like this? They what? Yeah, because now they're coated in electrons, and now this leaf and this leaf are both negative, so they kind of go, whoa, and they try to get away from one another. That all making sense? What does the grounding do? Well, I can absorb a lot of electrons, especially since I'm standing on the floor, and so the electrons can actually go through me and go into the floor if they need to, if there's a lot of electrons, which is probably not necessary because they can probably just absorb into my body. But when I go like this, what am I giving the opportunity for those electrons to do? Because they want to get away from each other, they can go into me. I look like a good source to spread out, so they go shoop into me, and now what are we left with here? Is that thing negative, positive, or neutral? After I touch it? Neutral. So once again, do the whole demo. It starts, that thing's neutral right now, meaning it's got the same number of positives and negatives. Now I charge this up. It doesn't sound very chargy. There it goes. Yeah, I know. It's on my shirt too. Now it's charged up pretty good. I touch it. Boom. The negatives have now left, some of them have left the wand, they've gone into the electroscope. This thing's called an electroscope, by the way. I touch it, zzz, they drain into me, it's neutral again. Good? So that's one demo. The other demo, kind of interesting, but I need an assistant this time. And you're going to have a simple job. Your job is simply, when I tell you to, you need to ground this thing. And the way you ground it is you're just going to use one finger and you're going to touch the red pith ball. Pith is like styrofoam, okay? Pith. They used to make pith, just a social studies thing. Pith helmets. Have you heard of that? World War I? They used pith to make the helmets because it absorbs shock well. And so they were experimenting with wearing helmets because people were getting their heads cracked open a lot during war times. So they started wearing helmets and they used pith helmets. That's a pith helmet. Now my problem is I'm electrically charged because I've been messing with this. So every time I touch it, I'm not really grounding it anymore. So your job would be to reach out and ground it. Why don't you go ahead and do that? Okay? And you can either just touch it, or you can just do this lightly for a second. That'll make sure. So do it again just to make sure we don't have a charge on it. Alright. So it's grounded now, meaning it's got how many positives and negatives in comparison? Same. So if we got the same positives and negatives, and I charge this up here, see how it's a little bit attracted? It wants to come. I'm not going to let it touch, but I can kind of manipulate it and pull it a little bit. Because, what is this?
Negative.
That's neutral. but neutral means it's got positives and negatives. So if I go like this, where do the negatives go on the red pith ball?
Opposite side of the ball.
Opposite side. What's left on the close side?
Positive.
So if there's positives left on the close side, what do they want to do to the negatives?
Connect to it.
They want to get together with the negatives. So when I go like this, you can see they're kind of attracted. All right? You catching what's going on here? Negatives can move. Can positives move? No. Where are positives contained in the atom?
Nucleus.
Nucleus. You can't move the nucleus. The nucleus is where it is. It's not moving. But the negatives can move around. So when I go like this, I push the negatives to the other side. The positives stay still. Now it's positive. Now it's attracted to my wand. Got it? Now, if I do this, and I actually do touch it now, let it attract. Now, look at it. Now it hates me. Now the thing is like opposed to me. I messed it up because I let it touch the pole. You ground it again. Let's try that again. Alright, so it's grounded. It's attracted to me. I touch it, now it's repelled. Now I can actually push it. Look at that, cool, huh? Well, how did that happen? Okay, how did that work? So, this was negative. I touched it, and when I touched it, what happened to some of the negatives?
Yeah, they transferred to
They transferred, so now this is negative and this is negative. Now it just doesn't like me anymore.
Nope.
Okay, but now, grounder, can you just, with your fingertip, just touch that red pith ball and watch what happens? Boom. Did you see what it did? I didn't want it to touch me, that messes things up. Alright, oh, it's coming after me. Why does it keep coming after me? Because I'm a good source for the electrons to go into me, and it figures that out. It's like, I'm acting like electrons can think. They can't think, but they react in the same predictable way. So when you touch that again, watch what happens quick. It goes to the wand, then it goes away from the wand again. Did you catch all that? So why is it doing that? So, I touched it, what did it do at first?
stayed connected.
Oh, my pith ball broke. So, a very fragile pith ball, apparently. So I touch it, and then it stays away from me. Then the grounder comes over and grounds it. What did you do to the electrons?
Took them.
You took them! You took them onto your body. The electrons are with you now, so this thing is now positive, so it goes zoom, and it comes right over here. But then what did it do when it touched the wand again?
Went back out.
It got electrons back on it. And once the electrons are back on it, what did it do? Now it doesn't like me again. And back and forth it goes. You can do that like for quite a while, actually. Alright? The last demo I want you to see, it's not really a demo at all, it's kind of just lame, but it's a visualization that'll help us talk about something in a minute. This guy, Charles Coulomb, eventually figured out how much force there is between things with charged particles. And the way he did it is he set up an apparatus a lot like this. He had a tube, in this case it's like a plastic type of insulated tube, and then he could charge up the wand, and then he could move the tube. See how I can move the tube? I'm not actually touching it, but I can move it using the static electricity. And he measured how much he could turn the tube with certain amounts of charge. So he said, okay, I have this much charge, 5. And when I use 5 of charge, it twists that half a turn. And he made kind of a ratio of proportion. Eventually he came out with Coulomb's law, which is how we determine how strong different charges are. So I just wanted you to see that so you could kind of understand what he was all about. How many minutes we at, videographer?
14.
Let's stop it.